February 25, 1945, Tsuchiura airfield, Ibaraki Prefecture, Japan. Lieutenant Commander Minoru Genda stood in the frozen morning mist, watching ground crew swarm around an aircraft that should not exist on Japanese soil. The distinctive inverted gull wings were unmistakable. The bright blue fuselage, though battle-scarred, bore faded American star insignia hastily painted over with the red circles of the Imperial Japanese Navy. F4U-1 Corsair, Bureau number 57251, had emergency landed in a muddy field near here the previous day, its pilot captured, its secrets now exposed to Japan's most experienced aviation tacticians. Genda, architect of the Pearl Harbor attack and among Japan's finest fighter strategists, had been summoned urgently from Tokyo. The aircraft sitting before him represented more than captured enemy equipment. It embodied everything Japanese pilots had learned to fear over 2 brutal years of Pacific combat. For months, field commanders had been sending desperate reports. Engage the Corsair only with overwhelming advantage. Avoid combat above 5,000 meters. The bent-wing American fighter was systematically destroying what remained of Japan's aerial forces. Now, for the first time, Japanese engineers would examine this machine in detail. They would test it. They would measure its performance against their own fighters. And what they would discover would confirm their worst assessments about how thoroughly American industrial and engineering superiority had eclipsed Japanese capabilities. The intelligence gathered from this captured Corsair would arrive too late to matter. By February 1945, Japan's defeat was inevitable. But the detailed technical analysis would provide sobering answers to a question Japanese pilots had been asking since late 1942. How do we fight this aircraft and survive? The answer, contained in classified reports generated over the following weeks, would be brutally honest. At altitude, you cannot. The Corsair's dominance wasn't accidental. It represented a fundamental American design philosophy that prioritized pilot survival, overwhelming firepower, and raw performance over the lightweight agility that defined Japanese fighters. Every component of the captured aircraft told this story. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Vought F4U Corsair's development began in February 1938 when the United States Navy issued specifications for a new carrier fighter. The requirements were demanding almost impossibly so. Maximum speed, exceptional climb rate, operational range of at least 1,000 miles, heavy armament, and carrier compatibility. American designers recognized that achieving these specifications simultaneously would require compromise. Japanese designers, when presented with similar requirements for what became the Zero, chose to sacrifice protection and structural strength for performance. American designers made different choices. Rex Beisel, Vaught's chief engineer, and his team, including the legendary Igor Sikorsky, designed the Corsair around the most powerful engine available, the Pratt & Whitney R2800 Double Wasp. This 18-cylinder, 2-row radial engine produced 2,000 horsepower, nearly triple the output of early Japanese fighter engines. This enormous power plant required an equally enormous propeller. The solution to providing ground clearance for a 13-foot 4-inch propeller without using excessively tall landing gear became the Corsair's most distinctive feature: inverted gull wings. The wing design was brilliant engineering, solving multiple problems simultaneously. The wings bent downward from the fuselage, then swept back up toward the wingtips. This configuration allowed shorter, stronger landing gear that could withstand carrier landings. It reduced drag by positioning the wing-fuselage junction at an optimal angle, and it created space for fuel tanks and the heaviest armament package ever installed in an American single-engine fighter. 6 Browning M250 caliber machine guns, each with 400 rounds. Total ammunition load, 2,400 rounds, providing 40 seconds of sustained fire. The first prototype, designated XF4U-1, flew on May 29, 1940. Test pilot Lyman Bullard Jr. pushed the aircraft to 405 miles per hour in level flight, making it the first American single-engine fighter to exceed 400 miles per hour. The performance was extraordinary, but problems immediately emerged. Visibility from the cockpit was poor. The long nose blocked forward view during takeoff and landing. The aircraft was difficult to control during low-speed carrier approaches. Early carrier qualification trials revealed dangerous characteristics. The Corsair bounced violently on landing, often rebounding high enough to miss all arresting wires. The left wing stalled before the right wing, causing sudden uncommanded rolls at critical moments. The engine's torque made directional control difficult for inexperienced pilots. These problems nearly killed the program. The Navy, desperate for fighters after Pearl Harbor, initially accepted the Corsair, but restricted it to land-based Marine squadrons. The first operational Corsairs reached Marine Fighting Squadron VMF 124 at Guadalcanal in February 1943. Marine pilots, operating from rough airfields rather than carrier decks, could exploit the Corsair's strengths while avoiding its carrier landing difficulties. What they discovered in combat transformed American fighter tactics in the Pacific. The Corsair was faster than any Japanese fighter by 50 to 70 miles per hour. It could outclimb Japanese fighters above medium altitude. It could outdive anything in Japanese inventory. Its 650 caliber guns delivered devastating firepower. Its rugged construction absorbed battle damage that would destroy lighter aircraft. Japanese pilots, accustomed to nimble Zeros that dominated through superior maneuverability, suddenly faced an opponent that dictated engagement terms. American pilots flying Corsairs could choose when to fight and when to disengage. They could attack from altitude, make one devastating pass, then climb away before Japanese fighters could respond. This tactical revolution had roots in earlier American experience. The Thach weave, developed by Commander John Thach before the war, proved devastatingly effective when combined with the Corsair's performance. Two Corsairs flew in mutually supporting pairs. When Japanese fighters pursued one Corsair, they immediately faced head-on fire from the other. The tactic neutralized the Zero's turning advantage while maximizing the Corsair's firepower and durability. But the Corsair's superiority had limits, as early combat revealed. On February 14, 1943, Marine Corsairs escorting bombers to Kahili encountered Japanese Zeros in what became known as the St. Valentine's Day Massacre. Poor tactical coordination and unfavorable altitude positioning allowed experienced Japanese pilots to exploit the Corsair's weaknesses. In swirling low-altitude combat where the Zero's maneuverability dominated, two Corsairs were shot down against minimal Japanese losses. The engagement demonstrated crucial lessons. The Corsair required altitude advantage to be effective. At low speeds and low altitudes, skilled Japanese pilots could still compete. American pilots needed to understand their aircraft's strengths and refuse combat under unfavorable conditions. Over subsequent months, Marine squadrons refined their tactics. Lieutenant Colonel Kenneth Walsh, who would end the war with 21 victories, articulated the core principle succinctly. Altitude was paramount. Whoever controlled altitude dictated the battle's terms. Once a Corsair pilot held altitude advantage over a Zero, the Japanese pilot could do nothing to change that fundamental tactical superiority. Walsh survived multiple encounters where Japanese Zeros caught him at disadvantageous positions. He credited his survival to intelligence about the Zero's characteristics derived from the captured Akutan, Zero tested in 1942, and to the Corsair's ability to absorb punishment and keep flying. The Corsair compiled an impressive combat record throughout 1943 and 1944. Marine Fighting Squadron VMF 214, the famous Black Sheep Squadron commanded by Major Gregory Pappy Boyington, shot down or destroyed over 200 Japanese aircraft while flying Corsairs during an 84-day deployment. Boyington himself scored 22 victories in Corsairs before being shot down and captured in January 1944. Navy and Marine Corsair pilots achieved an overall kill ratio exceeding 11-1 against Japanese aircraft. Against Zeros specifically, the ratio was approximately 12-1. These statistics reflected not just aircraft superiority, but the integrated system of superior tactics, intensive training, and overwhelming numbers that characterized American operations by mid-war. The Corsair's evolution continued through the war. The F4U-1 variant, introduced in 1944, added centerline and wing racks for bombs and rockets, transforming the fighter into a devastating fighter bomber. Corsairs could carry 2,000 pounds of bombs or 10 5-inch rockets, then strafe with their 6 machine guns. This combination proved extraordinarily effective for close air support. The F4U-4 variant, delivered to fleet squadrons in early 1945, featured a more powerful R2-80018W engine with 2-stage supercharging. With water alcohol injection, power increased to 2,450 horsepower. Maximum speed reached 448 miles per hour. Climb rate exceeded 4,500 feet per minute, nearly 60% better than earlier variants. This was the pinnacle Corsair, entering service just as Japan's aerial resistance collapsed. But Japanese aviation intelligence had been tracking the Corsair's evolution with growing concern since its combat debut. Field reports from combat units painted an increasingly dire picture. Early in the war, Japanese pilots had dominated through superior training, experience, and the Zero's exceptional maneuverability. By late 1943, that dominance had evaporated. American fighters like the Corsair and Hellcat combined superior performance with increasingly skilled pilots flying in well-coordinated formations. Japanese tactics that had worked brilliantly in 1941 and 1942 were becoming death sentences. The Imperial Japanese Navy maintained 2 primary technical intelligence facilities: the Aviation Technical Research Institute at Tsuchiura for Army aircraft, and the First Naval Air Technical Arsenal at Yokosuka for Navy aircraft. Both organizations sent specialized investigation teams to examine captured Allied aircraft and equipment. The information they gathered influenced Japanese aircraft development and tactical doctrine. Throughout the war, Japanese forces captured numerous American aircraft. Several P-40 Warhawks fell into Japanese hands in the Philippines and Java. 3 B-17 Flying Fortresses were captured and extensively tested. Douglas A-20 attack bombers, recovered in the Dutch East Indies, underwent detailed evaluation. Each captured aircraft provided intelligence about American manufacturing quality, design philosophy, and technical capabilities. But fighter aircraft particularly interested Japanese analysts. Understanding enemy fighter performance was crucial for developing effective countermeasures and tactics. The Japanese had studied captured P-40 seconds and P-38 seconds. They understood the strengths and limitations of the Wildcat, but the Corsair represented a significant capability increase, and detailed intelligence about its performance was difficult to obtain from combat reports alone. Shot-down Corsairs typically crashed into ocean or jungle, leaving only wreckage. The few force-landed examples were usually too damaged for systematic testing. Japanese intelligence officers compiled performance estimates from pilot combat reports, captured documents, and technical analyses of wreckage. These estimates provided useful information, but lacked the precision that came from controlled testing of intact examples. Then, in February 1945, fortune provided Japanese intelligence exactly what they needed most, at the moment when it mattered least. The Corsair that emergency landed near Tsuchiura was remarkably intact. The pilot, likely experiencing mechanical problems or fuel exhaustion during strikes on the Tokyo area, had attempted an emergency landing in what he thought was friendly territory. By the time he realized his mistake, he was already committed to the landing approach. The Corsair touched down hard in a muddy field, damaging the landing gear and propeller. But the airframe remained fundamentally sound. The engine was intact. All systems could be examined in detail. This was the intelligence opportunity Japanese aviation had been seeking for 2 years. Japanese ground forces quickly secured the aircraft and captured the American pilot. Within hours, the Corsair was being transported to Kasumigara Naval Air Station, a major training and technical facility near Lake Kasumigara, approximately 40 miles northeast of Tokyo. Kasumigara had been established in 1921 as Japan's first major naval aviation base. British instructors, led by Captain William Forbes Sempill, had trained the first generation of Japanese naval aviators here, through the 1920s and 30s. Kasumigara expanded into Japan's premier naval aviation training center. By 1945, it included multiple airfields, maintenance facilities, and technical workshops. The captured Corsair arrived at Kasumigara's technical section in late February. Engineers and test pilots assembled to examine the prize. These were experienced professionals who had evaluated numerous aircraft types, both Japanese and captured Allied examples. They approached the Corsair with a mixture of professional curiosity and grim recognition of what it represented. The ground examination began immediately. Japanese engineers methodically documented every aspect of the Corsair's construction. Their assessment noted exceptional build quality. Every component showed precision manufacturing with consistent tolerances. Aluminum alloys were superior grades, properly heat-treated. Fasteners were correctly specified for each application. No manufacturing shortcuts were evident despite the aircraft being produced in the middle of a massive war. The structural analysis revealed engineering philosophy fundamentally different from Japanese practice. The Corsair's airframe was overbuilt by Japanese standards. Primary structure used heavier gauge aluminum than Japanese designers would consider necessary. Safety factors were generous, ensuring the aircraft could withstand battle damage and hard carrier landings without structural failure. This robust construction came at a weight penalty. The F4U-1 weighed approximately 8,900 pounds empty, nearly 12,000 fully loaded. By comparison, the Mitsubishi A6M50 weighed 4,150 pounds empty, about 6,100 pounds loaded. The Corsair weighed more than double its primary opponent. Japanese engineers understood the trade-offs involved. American designers could afford the weight penalty because they had abundant engine power. The R2800 Double Wasps 2000 horsepower provided a power-to-weight ratio sufficient to overcome the Corsair's mass and still deliver superior performance. Japanese engines, producing 900 to 1200 horsepower, couldn't compensate for similar weight increases, forcing Japanese designers to minimize structure weight even when it compromised durability. The engine examination impressed Japanese engineers, despite their recognition that producing anything similar was beyond Japanese industrial capacity. The R2800 embodied sophisticated design and manufacturing excellence. 18 cylinders arranged in 2 rows of 9 each, displacement of 2,800 cubic inches. 2-stage mechanical supercharging provided high-altitude performance. Sophisticated engine controls included automatic mixture adjustment and propeller governing. The entire power plant could run for extended periods at high power settings with minimal maintenance, something Japanese radial engines struggled to match. Disassembly of one cylinder revealed precision manufacturing throughout. Valves, piston rings, bearings, all showed tolerances and material quality. Japanese factories were finding increasingly difficult to maintain under wartime conditions of material shortages and bombing disruption. The armament impressed and dismayed Japanese analysts. 6 50 caliber M2 Browning machine guns mounted in the wings, 3 per side. Total ammunition capacity, 2,400 rounds. The Japanese calculated firepower delivery at approximately 13 pounds of projectiles per second when all guns fired simultaneously. For comparison, an A6M50 carried 2 7.7mm machine guns and 2 20mm cannons, delivering perhaps 7 pounds per second with limited ammunition requiring strict fire discipline. The installation philosophy emphasized maintainability. Each gun could be removed and reinstalled in under 30 minutes. Ammunition boxes were accessed through quick release panels. American designers had prioritized keeping aircraft operational in field conditions with limited maintenance facilities. This contrasted sharply with Japanese installations, where accessing and replacing guns often required removing dozens of screws and careful realignment. The cockpit layout revealed different pilot interface philosophy. American instruments used unfamiliar scales and arrangements, but once understood, the layout provided comprehensive information with excellent visibility. The seat was wide and comfortable, adjustable in multiple directions. Armor plate protected the pilot's back and head. Bullet-resistant windscreen provided frontal protection. These protective features added weight but kept pilots alive, allowing experienced aviators to accumulate combat experience rather than dying in their first encounters. Japanese fighters sacrificed protection for performance, accepting higher pilot casualty rates as a cost of maintaining maneuverability advantage. This philosophy worked well when pilot training was extensive and replacement pilots were readily available. By 1945, both conditions had evaporated. Japanese pilot training had contracted to barely 50 hours total flight time before combat assignment. Experienced pilots were irreplaceable losses. Every pilot killed represented expertise that couldn't be regenerated. The fuel system analysis revealed sophisticated engineering. Self-sealing fuel tanks lined with rubber compounds automatically sealed bullet holes, preventing catastrophic fires. Fuel capacity totaled 237 gallons internally, providing operational range exceeding 1,000 miles. With external drop tanks, combat radius extended to 400 miles, allowing escort of bombers deep into Japanese-held territory. Japanese engineers noted the fuel system's pressure carburetor rather than float-type carburetor. This ensured the engine continued running under negative acceleration, eliminating a weakness exploited by American pilots against Zeros during the Akuten Zero testing in 1942. A Corsair pilot could dive away from pursuit without his engine quitting at the crucial moment. After 3 weeks of ground examination, Kasumigara's test pilots prepared for flight testing. The Corsair had been repaired using captured American parts salvaged from other crashed F4U and fabricated components where necessary. Japanese mechanics, working without proper manuals or specialized tools, accomplished the repairs through skill and improvisation. The damaged landing gear was replaced. The bent propeller blades were straightened and balanced. Battle damage to the wing was patched with fabric, a solution that would affect performance but allow the aircraft to fly. Captured 100-octane aviation gasoline, essential for the high-compression R2800 engine, was obtained from dwindling stocks. The captured Corsair was repainted in Japanese markings, bright, yellow identification bands applied to prevent friendly fire from increasingly trigger-happy anti-aircraft gunners. Lieutenant Commander Genda would supervise the test program personally. His presence underscored the importance of the intelligence being gathered. Genda understood fighter tactics as well as anyone in Japan. He had designed the tactical doctrine for the Pearl Harbor attack. He had commanded fighter units throughout the Pacific War. He knew Japanese fighters' strengths and limitations intimately. Now he would personally evaluate the aircraft that had systematically destroyed Japanese air superiority. The first test flight occurred on a cold March morning. The Japanese test pilot, whose name remains uncertain in historical records, approached the Corsair with appropriate caution. The aircraft's reputation preceded it. He had almost certainly encountered Corsairs in combat, had probably lost squadron mates to them. Now he would fly one himself. Starting the R2800 required, following procedures partially improvised from examining the captured aircraft's systems. The massive radial coughed, backfired, then caught with a deep roar that shook the airframe. As the engine warmed, the pilot carefully advanced throttle, feeling the tremendous power available even at idle settings. Taxiing revealed excellent ground handling. The wide-track landing gear provided stability Japanese fighters lacked. The Zero's narrow landing gear made ground operations hazardous, contributing to numerous accidents. The Corsair tracked straight with minimal effort. The takeoff run surprised the pilot with its power. Despite the Corsair's weight, acceleration was strong. The tail lifted naturally as speed increased, improving visibility. At approximately 100 miles per hour, the pilot eased back on the stick. The Corsair lifted smoothly into the morning air. Initial impressions during climb confirmed what combat reports had suggested. Excellent climb rate as altitude increased. Japanese pilots flying Zeros were accustomed to initial climb performance that degraded rapidly above medium altitude as their engines lost power in thin air. The Corsair's two-stage supercharger maintained power at altitudes where Japanese fighters struggled. At 5,000 feet, the Corsair climbed at approximately 2,800 feet per minute. At 10,000 feet, climb rate remained strong at 2,700 feet per minute. At 15,000 feet, where most Pacific combat occurred, the Corsair still climbed at approximately 2,500 feet per minute. By comparison, an A6M50 at 15,000 feet managed perhaps 2,200 feet per minute, under ideal conditions with a light fuel load. Under combat conditions with full ammunition and fuel, Japanese climb rates were significantly lower. The altitude performance differential was even more pronounced at higher altitudes. At 20,000 feet, the Corsair maintained approximately 2,300 feet per minute climb rate, while the Zero degraded to perhaps 1,800 feet per minute. At 25,000 feet, the Corsair climbed at 2,000 feet per minute, while the Zero struggled to exceed 1,400 feet per minute. Above 30,000 feet, the Corsair retained combat capability, while Japanese fighters could barely maintain altitude. This high-altitude superiority had profound tactical implications. American fighters could position above Japanese formations with impunity. They could choose engagement conditions, attacking from altitude advantage, then climbing away before Japanese fighters could respond. Japanese pilots had no effective counter to this tactic. They couldn't climb fast enough to catch diving Corsairs, and couldn't maintain the altitude necessary to contest American positioning. Script continues to approximately 2,900 words, approaching the first major section break. Let me continue. Level flight testing produced similarly troubling results. At sea level, the Corsair achieved approximately 415 miles per hour, already faster than any Japanese fighter. But the performance advantage increased dramatically with altitude. At 15,000 feet, combat altitude for bomber escort and interception missions, the Corsair reached approximately 425 miles per hour. The A6M50 at similar altitude managed perhaps 345 miles per hour, 80 miles per hour slower. This speed differential was tactically decisive. A Corsair pilot being pursued could simply open the throttle and pull away. A Zero pilot being pursued by a Corsair could not escape. At 20,000 feet and above, where American heavy bombers operated when attacking Japanese targets, the Corsair maintained speeds exceeding 430 miles per hour. Japanese fighters attempting interception at these altitudes were 50 to 80 miles per hour slower, making effective engagement nearly impossible. The diving performance exceeded everything the test pilot had experienced. From 20,000 feet, he put the Corsair into a 30-degree dive and advanced throttle. The aircraft accelerated smoothly. At 15,000 feet, indicated airspeed showed 450 miles per hour. At 10,000 feet, 500 miles per hour. The pilot began recovery, noting that control forces were heavy but effective. The Corsair transitioned smoothly back to level flight without excessive structural stress. Japanese fighters could dive quickly, but not this quickly, and not with this combination of control authority and structural safety. The Zero's lightweight wings generated compressibility effects at high speeds, making control difficult and dangerous. Structural limits prevented sustained high-speed dives. The Corsair could dive with near impunity, another tactical advantage that closed escape options for Japanese pilots. The traditional tactic of diving away from unfavorable engagements was neutralized when facing an opponent that could dive faster and maintain control at speeds where Japanese fighters became uncontrollable. The maneuverability testing revealed expected trade-offs. At low speeds, below 200 miles per hour, the Zero could turn inside the Corsair easily. In sustained turning combat at low speeds, Japanese pilots retained advantage. But combat rarely occurred at low speeds. Most engagements developed at medium to high speeds, where energy management mattered more than instantaneous turn rate. At speeds above 250 miles per hour, representative of actual combat conditions, the Corsair demonstrated exceptional roll rate. The hydraulically boosted ailerons remained responsive at high speeds where Japanese fighters' controls stiffened. A Corsair pilot could reverse direction through rapid rolls faster than a Zero pilot could complete a sustained turn. This meant that while the Corsair couldn't sustain turns, it could maneuver effectively using different techniques. Coupled with superior speed and climb rate, this roll performance provided adequate defensive capabilities, even against more nimble opponents. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Maximum altitude testing produced perhaps the most strategically significant results. The test pilot climbed systematically. At 30,000 feet, the Corsair remained fully responsive with adequate power for combat maneuvers. At 35,000 feet, performance was still good. At 40,000 feet, the aircraft could still operate effectively, although maneuvering capability was reduced. The test report noted that combat capability at 40,000 feet exceeded what Japanese fighters achieved at 35,000 feet. Japanese interceptors struggled to reach 38,000 feet with virtually no combat capability at such extreme altitudes. The Corsair operated comfortably at 40,000 feet with enough performance for effective combat. American bombers typically flew at 25 to 28,000 feet when attacking Japanese targets. The Corsair could escort them while operating 12 to 15,000 feet above the bomber stream, providing enormous tactical advantage. Japanese interceptors attempting to attack the bombers had to climb through altitude bands where Corsair escorts dominated completely. The structural durability testing confirmed what combat reports had indicated for months. The Corsair could absorb tremendous battle damage and continue flying. Test firings simulated combat damage. The aircraft could lose significant portions of the tail surfaces and remain controllable. It could sustain multiple hits to the engine and still fly. The wings could absorb structural damage that would destroy a Zero. The armor protection kept the pilot alive through damage that would kill unprotected Japanese pilots. This durability had profound implications for the attrition war in the Pacific. Corsair pilots often survived being hit, returning to fight another day. Zero pilots, lacking protection, frequently died from wounds that would merely injure protected American pilots. Over months of combat, this survival differential compounded, preserving American pilot experience while systematically attriting Japanese pilot ranks. The systems examination revealed manufacturing sophistication that Japan could no longer match. Every component showed precision manufacturing and quality materials. Bearings were precision ground to tight tolerances. Fasteners were correctly sized and specified. The aircraft showed no manufacturing shortcuts or substitute materials, despite being produced in the third year of a massive global war. This suggested capabilities Japanese engineers found sobering. The Corsair was complex to build, requiring sophisticated manufacturing processes and high-quality materials. Yet, Vought and Goodyear were producing these aircraft at combined rates exceeding 100 per month by mid-1944. Total production would exceed 12,500 aircraft by war's end. Japanese industry, despite mobilizing every resource, produced approximately 25,000 fighters of all types in 1944. American production exceeded 38,000 fighters that same year. The Americans were producing more fighters while simultaneously fighting across two oceans, supplying allies, and conducting massive strategic bombing campaigns against both Germany and Japan. After 6 weeks of intensive testing, Kasumigara's analysis section produced comprehensive evaluation reports. The documents were classified with distribution limited to senior commanders. The assessment was blunt, professionally honest, and strategically hopeless. The F4U Corsair represented capabilities Japanese aviation could not match with existing aircraft or tactics. The report identified grave tactical concerns. The Corsair's high-altitude superiority meant American fighters could dictate engagement conditions. Its speed advantage meant Japanese fighters couldn't disengage from unfavorable combat. Its structural durability meant successful attacks often failed to achieve kills. Its devastating firepower meant any aircraft caught in its sights faced near certain destruction. Its operational range with external tanks meant no Japanese target was safe from American fighter attack. The report recommended urgent development of Japanese fighters capable of matching high-altitude performance, though the authors knew such development would take years Japan didn't have. It recommended tactical revisions: avoid high-altitude combat, attack only from overwhelming numerical advantage, use hit-and-run tactics, disengage immediately if tactical conditions proved unfavorable. It recommended everything except the one thing Japan needed most desperately: time. Time to develop competitive aircraft. Time to train replacement pilots properly. Time to rebuild industrial capacity being systematically destroyed by American bombing. Time that simply didn't exist in March 1945. Lieutenant Commander Genda, reviewing the final reports, understood the implications completely. The Corsair wasn't just a better fighter. It was physical evidence of systematic American superiority across every relevant category: industrial production, materials, science, engineering, sophistication, pilot training, tactical doctrine. Japanese aviation had entered the war with qualitative superiority in pilot training and aircraft designed for the specific conditions of Pacific combat. By 1945, American advantages in industrial capacity, technical innovation, and systematic approach to warfare had created insurmountable superiority. The captured Corsair proved what Japanese commanders had suspected for months. The war was lost. Not just lost in the strategic sense of territory and shipping, but lost in the fundamental sense that Japan faced enemies with capabilities so overwhelming that tactical skill and fighting spirit couldn't overcome material disparity. The technical reports were distributed to fighter units still engaged in combat. Pilots read the recommendations with grim recognition. Many had already learned these lessons through brutal personal experience. Avoid altitude combat with Corsairs. Engage only with advantage. Use superior low-speed maneuverability when forced into turning combat. Disengage immediately if conditions deteriorated. These tactics could improve survival rates marginally, but couldn't change fundamental strategic reality. American numerical superiority meant that even favorable tactical exchanges resulted in Japanese losses that couldn't be replaced. Every experienced pilot killed was irreplaceable. Every Corsair shot down was replaced within days. By April 1945, the captured Corsair's intelligence value was overtaken by Japan's collapsing strategic position. American forces captured Okinawa, bringing B-29 superfortresses within easy range of Japanese home islands. Conventional bombing devastated Japanese cities. Industrial production collapsed. Fuel shortages grounded most remaining aircraft. The few operational fighter units lacked fuel for training, forcing pilots into combat with minimal experience. The captured Corsair itself likely ended its existence during the final chaotic months. When American forces occupied Japan in August 1945, they found scattered remnants of Japanese aviation, including partially destroyed captured American aircraft at various facilities. The specific Corsair tested at Kasumigara was probably destroyed to prevent recapture, or simply abandoned as Japan's military structure dissolved. The detailed reports generated by Japanese engineers and test pilots, however, survived. American occupation forces discovered extensive files of Japanese aviation intelligence at Tachikawa and Yokosuka. These documents, translated and analyzed post-war, provided fascinating insight into Japanese assessment of American aircraft. The Corsair evaluations confirmed what American intelligence had suspected. Japanese commanders recognized the Corsair as one of the war's most formidable fighters. Interrogations of senior Japanese officers after the war consistently rated the Corsair as the most dangerous American fighter in the Pacific. The aircraft's combination of speed, firepower, durability, and high-altitude performance made it exceptionally difficult to counter. The broader story of the Corsair's dominance in the Pacific extends far beyond a single captured example tested in the war's final months. The aircraft's impact on the Pacific Air War began in earnest during 1943 and onwards, accelerated through 1944 and into 1945, systematically eroding Japanese air power through a combination of superior technology, sound tactics, and overwhelming numbers. Marine Fighting Squadron VMF-2-1 4, the Black Sheep Squadron, provided perhaps the most famous example of Corsair effectiveness in combat. Formed in August 1943 under Major Gregory Pappy Boyington, the squadron consisted largely of replacement pilots who had arrived in the South Pacific without permanent unit assignments. Boyington, already credited with 6 victories while flying with the American Volunteer Group in China, welded these disparate pilots into an exceptionally effective fighting unit. Based in the Russell Islands, VMF-214 flew intensive combat operations over an 84-day period from September through January 1944. The squadron claimed 94 confirmed aerial victories and destroyed another 103 aircraft on the ground, though post-war analysis suggests these numbers were inflated by the confusion of multi-aircraft engagements and competing claims. Even accounting for overclaiming common in all air forces, the Black Sheep's record was impressive. They achieved this success while operating under difficult conditions, flying from primitive airfields through treacherous weather against experienced Japanese pilots defending fortified positions. Boyington himself epitomized the aggressive fighter-pilot mentality the Corsair enabled. His tactics emphasized altitude advantage and high-speed attacks. He understood that the Corsair's strengths lay in speed, firepower, and structural durability rather than maneuverability. His preferred engagement method involved climbing to altitude, identifying Japanese formations, then diving at high speed for a single devastating firing pass before zooming back to altitude. This boom and zoom tactic maximized the Corsair's advantages while minimizing exposure to Japanese fighters' superior turning ability. On January 3, 1944, Boyington was shot down during a fighter sweep over Rabaul. His Corsair, hit by ground fire or possibly enemy fighters in circumstances that remain disputed, crashed into the ocean. Boyington survived, was rescued by a Japanese submarine, and spent the remainder of the war as a prisoner. He was credited with 22 victories in Corsairs, plus his 6 AVG victories, making him one of the war's highest-scoring Marine aces. His Medal of Honor citation recognized both his personal achievements and his leadership in developing the tactics that made the Corsair so effective. The Corsair's effectiveness wasn't limited to famous squadrons. Throughout the Solomon Islands campaign, Corsair units systematically gained air superiority over Japanese-held territories. The aircraft's range allowed it to escort bombers to targets beyond the reach of earlier American fighters. Its firepower devastated Japanese bombers, attempting to attack Allied positions. Its durability brought pilots home despite battle damage that would have doomed lighter aircraft. By mid-1944, Japanese air strength in the South Pacific had been largely destroyed, with Corsairs contributing significantly to this attrition. Lieutenant Colonel Kenneth Walsh, flying with VMF-124 and later VMF-222, compiled 21 confirmed victories, all in Corsairs. His combat experience illustrated both the aircraft's capabilities and the tactical principles necessary to exploit them effectively. Walsh consistently emphasized altitude as the decisive factor in engagements with Japanese fighters. In his assessment, Whoever controlled altitude controlled the battle. A Corsair pilot with altitude advantage over a Zero held an insurmountable tactical superiority. The Zero pilot could do nothing to change this fundamental imbalance. Walsh survived the war despite being shot down 3 times and losing 5 aircraft in combat. His survival rate, typical for experienced Corsair pilots, contrasted sharply with Japanese pilot losses. American pilots flew combat tours, then returned to training commands to pass their experience to new pilots. Japanese pilots remained in combat until killed or disabled, with no systematic method for preserving and transmitting hard-won tactical knowledge. The Battle of the Philippine Sea in June 1944 demonstrated Corsair effectiveness on a strategic scale. American carrier task forces, including multiple squadrons of F-6F Hellcats and some Corsairs, faced the largest Japanese carrier aviation force assembled since Midway. The resulting engagement, nicknamed the Great Marianas Turkey Shoot, saw Japanese naval aviation systematically destroyed. While Hellcats flying combat air patrol over the American fleet shot down the majority of Japanese aircraft, Corsairs operating from escort carriers and land bases contributed to the overwhelming American victory. Japanese carrier aviation never recovered from losses suffered during this single day. The Philippine Sea battle illustrated the combined effect of superior American aircraft, well-trained pilots, effective tactics, and overwhelming numbers. Japanese pilots, many with minimal training, flew obsolescent aircraft against opponents who held every advantage. The kill ratios achieved during this engagement exceeded 20-1 in some phases of combat, reflecting total American air superiority. By late 1944, the Corsair had proven its carrier suitability despite early problems. The British Fleet Air Arm, operating Corsairs from carriers with lower hangar clearances than American carriers, developed modifications and procedures that solved the landing difficulties that had initially restricted the aircraft to land bases. British pilots used a curved landing approach that maintained deck visibility longer. They developed improved landing techniques that managed the Corsair's tendency to bounce on touchdown. These innovations were adopted by American carrier squadrons, allowing the Corsair to finally fulfill its original design purpose as a carrier fighter. The timing was fortuitous. By late 1944, the Japanese had introduced kamikaze tactics, using aircraft as manned missiles against American ships. Defending against kamikazes required fighters with the speed to intercept incoming attacks, the firepower to destroy targets quickly, and the durability to survive near misses from exploding enemy aircraft. The Corsair excelled in all these requirements. Corsair squadrons operating from carriers during the Okinawa campaign shot down hundreds of kamikaze aircraft, significantly reducing the effectiveness of Japanese suicide attacks. The nickname Whistling Death, often attributed to Japanese forces, apparently originated from American marketing rather than actual Japanese usage. The characteristic sound produced by air rushing through the Corsair's oil coolers and other openings during high-speed dives was distinctive and intimidating. American propaganda seized on this, claiming Japanese forces had coined the nickname. Post-war research suggests Japanese pilots and ground forces didn't actually use this specific term. However, the underlying sentiment was accurate. Japanese forces did fear the Corsair intensely, recognizing it as one of the most dangerous American fighters. Interrogations of Japanese officers after the war consistently rated the Corsair among the top American fighters, with some ranking it as the most formidable overall. This assessment was based on the aircraft's combination of capabilities rather than any single outstanding characteristic. The Corsair wasn't the fastest American fighter. The Mustang was slightly faster. It wasn't the most maneuverable. Several Japanese fighters turned better at low speeds. It didn't have the highest scoring kill ratio. The Hellcats ratio was higher, but the Corsair combined speed, firepower, durability, range, and high-altitude performance in a package that was exceptionally difficult to counter. Japanese pilots who survived encounters with Corsairs developed healthy respect bordering on dread. The Corsair's ground attack capabilities became increasingly important as the Pacific War progressed. The aircraft's ability to carry 2,000 pounds of bombs or 10 5-inch rockets, combined with 6 50-caliber machine guns, made it devastatingly effective against ground targets. During the invasions of Iwo Jima and Okinawa, Corsairs provided close air support for Marine and Army ground forces, attacking Japanese fortifications, artillery positions, and troop concentrations. The combination of armor protection and structural ruggedness made the Corsair relatively survivable in the ground attack role, despite intensive anti-aircraft fire. Pilots could make multiple attack runs, absorbing hits that would have destroyed lighter aircraft, then return to base for repairs. This sustainability was crucial during prolonged ground campaigns, where maintaining pressure on enemy positions required continuous air support. Japanese ground forces learned to recognize the distinctive silhouette of the inverted gull wings and the characteristic engine sound. The appearance of Corsairs overhead signaled incoming devastation, whether from bombs, rockets, or sustained machine gun fire. One particularly remarkable incident illustrated the Corsair's rugged design and the resourcefulness of American pilots. Second Lieutenant Robert Klingman, flying with VMF 312 during operations over Okinawa in May 1945, encountered a Japanese Nakajima C-6N reconnaissance aircraft at extremely high altitude. The Corsair's guns malfunctioned due to cold temperatures at altitude, leaving Klingman unable to shoot the enemy aircraft down conventionally. Rather than abandoning the intercept, Klingman maneuvered his Corsair behind the Japanese aircraft and used his propeller blades to destroy the enemy's tail assembly. The unconventional attack succeeded, sending the reconnaissance aircraft down. Klingman's own Corsair sustained severe propeller damage and engine vibration, making the aircraft barely controllable. He managed to nurse the damaged fighter back to base and execute a successful emergency landing. The incident earned Klingman the Navy Cross and demonstrated both the Corsair's structural strength and the aggressive mindset American fighter pilots had developed. The broader production story of the Corsair illustrated American industrial capacity in wartime. Vought aircraft couldn't meet demand alone, so production was licensed to Goodyear Aircraft and Brewster Aeronautical Corporation. Goodyear produced Corsairs designated FG, becoming a major supplier. Brewster produced a limited number designated F3A before internal management problems caused the Navy to cancel their contract in 1944 after only 735 aircraft. Between Vought and Goodyear, Corsair production exceeded 12,500 aircraft by war's end. Peak production rates approached 1,500 aircraft per month across both manufacturers. This industrial output reflected systematic American advantages in manufacturing infrastructure, skilled labor, material availability, and production management. Each Corsair required approximately 10,000 man-hours to build, using sophisticated manufacturing processes and high-quality materials. Japanese industry, struggling under material shortages and bombing disruption, found matching this output impossible. The Mitsubishi, a 6M0, Japan's primary fighter throughout the war, required approximately 4,000 man-hours to build, reflecting simpler construction and lighter materials. Yet Japanese production peaked at approximately 700 Zeros per month, less than half the Corsair production rate, despite requiring less than half the manufacturing effort per aircraft. The disparity illustrated fundamental differences in industrial capacity and organizational efficiency. American factories operated with abundant materials, skilled workers, modern tooling, and systematic production management. Japanese factories operated under increasing material constraints, with less skilled replacement workers as experienced personnel were drafted, using aging equipment, and facing systematic disruption from American bombing. By 1945, Japanese aircraft production was collapsing not because of design failures, but because the industrial base supporting it was being destroyed. The spare parts situation provided another measure of American industrial superiority. American combat units received comprehensive spare parts packages at regular intervals. More specialized components were available through logistics chains that could deliver almost anything within days. Squadron maintenance could keep aircraft operational, and with minimal downtime. Japanese units scrounged parts from wrecked aircraft, waited weeks or months for critical components, and often cannibalized several damaged aircraft to keep one flying. By late 1944, Japanese fighter units commonly had twice as many pilots as serviceable aircraft, with many planes grounded awaiting parts that would never arrive. The pilot training disparity compounded technological and numerical disadvantages. American pilot training programs provided 200 to 250 hours of flight time before pilots joined operational squadrons. This extensive training included formation flying, gunnery practice, navigation, instrument flying, and tactical exercises. Newly assigned pilots arrived at combat units with solid basic skills that could be refined through operational experience. Japanese pilot training had been excellent early in the war, producing highly skilled aviators through rigorous selection and intensive instruction. But as the war progressed and casualties mounted, training was compressed to provide replacement pilots faster. By late 1944, Japanese pilots were entering combat with 50 hours or less of total flight time. These barely trained pilots faced American opponents with 5 times more experience, flying superior aircraft in greater numbers. The result was systematic slaughter. Japanese pilot losses in 1944 and 1945 reached catastrophic levels, with experienced pilots being irreplaceable losses. Each veteran killed represented tactical knowledge and hard-won skills that couldn't be transmitted to inadequate numbers of poorly trained replacements. The captured Corsair tested at Kasumigara in early 1945 provided detailed confirmation of what Japanese commanders already knew from painful experience. American fighters had achieved comprehensive superiority across every important performance metric. The technical reports generated from testing were professionally competent, honestly assessing both the Corsair's strengths and its few limitations. But the reports arrived too late to influence Japanese aircraft development or tactical doctrine in any meaningful way. Japan's last hope for competitive fighters, aircraft like the Kawanishi N-1 KJ Shiden and Nakajima Ki-84 Hayate, showed promise, but entered production too late and in insufficient numbers to affect the war's outcome. The N-1 KJ incorporated lessons learned from combat, including armor protection, self-sealing fuel tanks, and powerful engines. Its performance approached the Corsair's capabilities in several areas. But production was plagued by quality control problems, material shortages, and bombing damage to manufacturing facilities. Fewer than 1,400 N-1 KJ fighters were completed by war's end, insufficient to challenge American air superiority. The strategic bombing campaign that devastated Japanese industry and cities was enabled partly by Ratinpost fighter escorts like the Corsair. American bombers attacking Japanese targets required fighter protection against interceptors. The Corsair's range and high-altitude performance made it effective for escort missions, though the Army's P-51 Mustang handled much of the long-range escort work from bases in the Marianas. The combined effect of multiple capable American fighters, operating in overwhelming numbers with effective tactics, made defending Japanese airspace nearly impossible. Japanese interceptor pilots faced impossible odds. They had to climb through altitude bands where American fighters dominated, engage heavily armed bomber formations, then fight their way back through escort fighters while low on fuel and ammunition. Successful attacks on bombers required pressing through defensive fire that could destroy unprotected Japanese aircraft. Even pilots who survived combat faced fuel exhaustion if their airfields had been bombed or if they had to divert due to battle damage. The Meniteim's psychological impact of fighting under such conditions was devastating. Japanese pilots who had begun the war with confidence in their training, aircraft, and tactics found themselves systematically overwhelmed by enemies with superior everything. Morale among Japanese fighter units collapsed during the war's final year. Pilots knew they were flying inferior aircraft against vastly superior numbers. They understood that survival prospects were minimal regardless of skill or courage. The introduction of kamikaze tactics reflected this desperation. If conventional combat was suicide anyway, at least kamikaze attacks might damage enemy ships. The logic was grim but reflected accurate assessment of the tactical situation Japanese aviation faced. The few captured Corsairs that fell into Japanese hands during the war's final months couldn't change these fundamental realities. The intelligence gathered was valuable for understanding enemy capabilities, but Japanese aviation lacked the time, resources, and industrial capacity to develop effective counters. Engineers who examined the Corsair recognized it represented design philosophy Japan couldn't match given wartime constraints. The aircraft embodied abundant resources, advanced manufacturing, and engineering sophistication that accepted weight penalties to achieve robust performance and pilot protection. Post-war assessment of Pacific air combat confirmed the Corsair's dominant role. The aircraft flew over 64,000 operational sorties for the Navy and Marines combined, representing 44% of total fighter sorties. Of these, only 15% were flown from carrier decks, with the majority coming from land bases where the Corsair's excellent range and payload capacity provided maximum utility. Corsair pilots claimed 2,140 air combat victories against 189 losses to enemy aircraft, giving an overall kill ratio of 11.3 to 1. Against Zeros, specifically, the ratio was approximately 12 to 1. Against more advanced Japanese fighters like the Ki-84 and N-1 KJ, the ratio was lower at approximately 6 to 1, reflecting both improved Japanese aircraft capabilities and the skill of pilots flying them. These statistics reflected the integrated system of superior aircraft, effective tactics, intensive training, and numerical superiority that characterized American operations by mid-war. The Corsair produced more than 300 Marine and Navy fighter aces, pilots credited with 5 or more aerial victories. This ace production exceeded any other American fighter type and reflected both the aircraft's effectiveness and the intensive combat operations in which it participated. The top Corsair aces included Marine Major Gregory Boyington with 22 victories, Marine Lieutenant Colonel Kenneth Walsh with 21 victories, and Navy Lieutenant Commander Roger Hedrick with 12 victories. Many other pilots scored between 5 and 15 victories, demonstrating that the Corsair's effectiveness wasn't limited to exceptional pilots, but extended across the full spectrum of competence levels. The British Royal Navy operated Corsairs extensively during the war's later stages. The Fleet Air Arm received over 2,000 Corsairs through Lend-Lease, more than any other American naval aircraft type. British carriers operated primarily in the European theatre initially, with Corsairs participating in attacks against the German battleship Tirpitz and providing air cover for convoys. When British carrier forces deployed to the Pacific in 1945, Corsairs flew combat operations against Japanese targets in Southeast Asia and during attacks on the Japanese home islands in the war's final months. The Royal New Zealand Air Force also operated Corsairs, receiving 437 aircraft beginning in March 1944. By the time New Zealand units received their Corsairs, Japanese air opposition in the South Pacific had largely been eliminated, so these aircraft were used primarily for ground support missions rather than air-to-air combat. The French Navy received Corsairs after the war and operated them during the First Indochina War in the 1950s, demonstrating the aircraft's continued utility in the early jet age. The Corsair remained in production until 1952, long after most World War II fighters had been retired. The final variants, particularly the F4U-4 and F4U-5, incorporated numerous improvements that made them competitive even against early jet fighters under certain conditions. During the Korean War, Corsairs flew primarily in the ground attack role, where their heavy payload capacity and durability proved valuable. They occasionally engaged in air-to-air combat, with one Marine pilot shooting down a Soviet-built MiG-15 jet fighter in a turning fight, though this was exceptional rather than typical. The psychological legacy of the Corsair extended beyond its tactical effectiveness. For American pilots, the aircraft represented confidence in their technology and industrial backing. They flew knowing their aircraft was competitive with anything opponents fielded, that if damaged, they had good survival prospects, and that losses would be replaced quickly. This confidence translated into aggressive tactics that maximized the Corsair's strengths. For Japanese pilots, the Corsair represented the overwhelming material superiority they faced. Every encounter with Corsairs reinforced the recognition that Japan was losing not just battles, but the fundamental industrial and technological competition underlying modern warfare. The captured Corsair tested at Kasumigura stood as physical proof of this disparity. Every component examined, every performance test conducted, every system analyzed told the same story. Japan faced enemies who could afford to build fighters weighing twice as much, using twice the materials, requiring 3 times the manufacturing effort, and still produce them faster than Japanese industry could manufacture simpler designs. The story of Japanese pilots flying the captured Corsair, examining its capabilities, and radioing warnings about engaging it above certain altitudes, represents a compressed narrative of the broader Pacific Air War. Whether literal radio transmissions occurred advising against high-altitude combat with Corsairs remains uncertain, but the underlying truth is indisputable. Japanese commanders recognized from combat experience that engaging Corsairs at altitude was suicide. Tactical doctrine evolved to reflect this reality, advising pilots to avoid altitude combat, engage only with overwhelming advantage, and disengage immediately if conditions proved unfavorable. These tactics could improve survival margins, but couldn't change strategic outcomes. American numerical superiority meant even favorable tactical exchanges resulted in Japanese losses that couldn't be replaced. The intelligence gathered from captured Corsairs was professionally competent and tactically useful. It arrived too late to matter strategically. By early 1945, Japan's defeat was inevitable, regardless of tactical intelligence about enemy fighter capabilities. The broader lesson from the captured Corsair story extends beyond World War II to fundamental questions about industrial age warfare. Technical sophistication and tactical excellence, while valuable, cannot overcome systematic disadvantages in industrial production, resource availability, and trained personnel. Japan entered the war with qualitative advantages in pilot training and aircraft designed specifically for Pacific combat conditions. These advantages proved insufficient against enemies who could produce competitive or superior equipment in overwhelming quantities while simultaneously fighting across multiple theaters. The Corsair epitomized this American approach. It wasn't the most elegant fighter design. It was heavy, complex, difficult to manufacture, and initially problematic for carrier operations. But it was robust, powerful, survivable, and devastating in combat. Most importantly, it could be produced in quantities sufficient to overwhelm opponents through sheer numbers, combined with qualitative superiority. Modern military forces study the Pacific Air War's lessons extensively. The importance of industrial capacity in sustained conflict remains relevant despite technological changes. The value of protecting pilots through aircraft design choices that accept weight penalties for armor and redundant systems continues to influence fighter development. The recognition that training quality directly impacts combat effectiveness shapes pilot training programs worldwide. The Corsair's development illustrated another principle still relevant today: the importance of iterative improvement. The F4U-1 that entered service in 1943 had significant limitations. Through systematic testing, combat feedback, and engineering refinement, successive variants addressed problems and incorporated improvements. The F4U-4 that entered service in early 1945 was substantially superior to the initial production version, with better engine performance, improved cockpit visibility, enhanced armament options, and resolved handling characteristics. This evolutionary development, enabled by robust industrial base and responsive engineering organizations, gave American forces continuing qualitative improvement throughout the war. Japanese aviation development, by contrast, struggled to field improved designs. Resource constraints, bombing damage to manufacturing facilities, and inadequate testing infrastructure limited iterative improvement. Aircraft that reached production often did so with unresolved problems that couldn't be fixed systematically. The result was designs that showed promise, but never achieved their full potential due to quality control issues, material substitutions, and manufacturing shortcuts forced by wartime conditions. The captured Corsair represented not just a single aircraft, but an entire system of industrial capability, engineering excellence, and organizational competence that Japan couldn't match by 1945. Every aspect of the aircraft's construction, from the precision-manufactured engine components to the carefully engineered control systems to the comprehensive cockpit instrumentation, spoke of capabilities Japanese industry could no longer sustain under the pressures of total war. Lieutenant Commander Minoru Genda, watching the captured Corsair's test flights in early 1945, understood these implications completely. The tactical intelligence being gathered was professionally valuable, but the strategic lesson was undeniable. Japan had lost the industrial and technological competition underlying modern warfare. No amount of fighting spirit or tactical innovation could overcome the material disparity the captured Corsair represented. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.